Hi everyone, and thank you for joining us for this Codefresh live event, Discovering and Fixing Dependency Vulnerabilities for Kubernetes Apps with Snyk and Codefresh. Let me introduce our first presenter, Dan Garfield. He is our Chief Technology Evangelist at Codefresh. He's a full-stack engineer and an all-around technology enthusiast. So with that, I will hand this off to Dan to get us started.
Thank you, Taryn. Thanks everybody for joining us. I'm actually pretty excited about this content that we put together for you today because we've learned a lot from all the videos we've done in the past, and we've really tried to increase the quality and make it so that you'll be able to walk away with code that you can take and implement and try yourself. And that's the goal. So we'd love to hear your feedback at the end and see how we did. As Taryn mentioned, we will share the slides. We'll send those out, as well as the video will be recorded so you can share it with your colleagues. And with that, let's see, Antoine, you want to share your screen? And I'll introduce Antoine is joining us from Snyk. He's our special guest this week and is a figure stuff out engineer at Snyk. He's had to figure some stuff out with this integration, and we didn't give him any help. We just said, hey, Anton, here's the deep end of the pool, jump in, let us know when you're done. And he made it happen. So that's a big win. So welcome, Antoine. We're glad to have you.
Thank you. Glad to be here. It wasn't that difficult. Codefresh is actually pretty easy to use. So that it was pretty easy. So yeah, I'm a figure stuff out engineer at Snyk. It's another name that I use for pre-sales engineers. So, I help organizations using open source security. And that's basically what we're going to talk about today. So, open source is just, I think, awesome. It allows you to do a lot of things and with really little amount of code. So it's, I think from what I've seen in all these different companies, it's a clear win. Open source is pretty ubiquitous, used absolutely everywhere. I was actually surprised. I thought it wouldn't be that much, but it's absolutely everywhere. And there are a couple of things that you need to understand behind that. So when we look at the apps, typically like the way that looks, the code that you write is actually tiny in comparison to the rest of the code that is being used. So by the means of libraries that are typically an open source code, you can like pull that with various package managers like Node and Maven and so on. But these libraries are basically portions of codes that you haven't written, that you haven't looked into, but are providing a lot of features for you. So it's a lot of productivity gain, a lot of things that you don't have to necessarily recreate the wheel every single time for. And along the same lines, the base image also kind of brings in the OS level components for the app, meaning your custom code and the libraries to function as well. And a lot of it comes from open source dependencies typically. So, it's very powerful, which means that with very tiny code, you can actually build something absolutely like powerful and awesome. But there are a couple of things to know about is that there are typically also a way for vulnerabilities kind of to creep into your stack. And there are various reasons for that. Sometimes it's just plainly malicious, where if you heard of the typo squatting in NPM, for instance, that's pretty like spot on. People are trying to use that to convey and to inject vulnerabilities to basically compromise your applications. Some people kind of lurk in some Bitcoin miners in there. So there are plenty of like different angles to it, but it's basically a good way to get vulnerabilities in if you're a hacker, or if you're not a hacker and you're just like maintaining this library. It's actually pretty easy to have issues in there. And in a worst case scenario, you end up like Equifax, for instance. And by the same extent, the base image brings its own set of similar challenges, and understanding what you're using where and how to remediate things is a bit tricky. So,
yeah. Oh, sorry. I was just going to say, I think Equifax is a great example because that's an instance where there were known vulnerabilities in open source software that were just sitting there for a long time. And it does seem that most vulnerabilities, most times that people get hacked, it's because they have unpatched, well-known vulnerabilities that they haven't taken care of. And to the Bitcoin mining point, that's no joke, but it is probably the best case scenario. The best case scenario is somebody steals your compute time, and that's the penalty you pay, because having them take user data is 100,000 times worse. So that's the best case scenario, but hopefully we can avoid both those things with some smart, scanning.
Yeah, so a lot of it is, if you look at it, is not rocket science. Is really like getting the fundamentals, getting the old stuff fixed, and just doing these like fundamental things is actually not that straightforward. So, you use a lot of libraries themselves use a lot of other libraries, and you have comes these dependency trees building that become really, really bloated. And it's actually difficult to keep track of things like that. So, flagging things out of the blue and not knowing what to do about it, it's another challenge. So in Equifax, they actually knew about the issue. They just didn't get to fixing it fast enough. So at Snyk, we're trying to really like change this approach to empower developers to really fix things across the various language stacks and base image package managers that you're using, so you can be like confidently shipping an app and more an app in a context of in delivered as a Docker container in a safe and reliable manner, and also in a maintainable manner over time. Things happen.
And this is why we want to marry in the CI/CD pipeline, right? So that it's built into your code contribution kind of standards, where when someone writes code, when they add a library, it gets checked, and it's just always there and it's aware. And I think you're probably going to talk about this later, but Snyk actually keeps track of the packages you have. So if a new vulnerability pops up, I can get an alert and become aware of it. And I've already got my pipeline over here where I can actually integrate the changes and get them deployed really fast. So I'm not waiting for some kind of slow deployment process to patch things. Correct.
So, Snyk, like the idea of Snyk is integrating across the SDLC, and the CI/CD pipeline is a big part of it. We actually are earlier trying to feed this info earlier, also in dev cycle, for developers to consume this information directly on their machines or around the repo. And the CI/CD pipeline empowers a lot of mechanisms as well. And it's pretty established in a lot of places, so it's also a good spot to do a lot of that. And at the end of the day, is like keeping track of all this is definitely key. And anything we're going to scan is typically going to be monitored as well, so we can keep an eye on your applications and test it every day, because tomorrow morning something new might be disclosed that is impacting some of your dependencies, whether they are used directly or indirectly. So it's a bit of a difficult problem that we're really trying to make easy. So the flow behind this, like through the pipelines automation, really makes it really easy to focus on developing your apps and really shipping that very fast to wherever it goes, typically to production. So it's really like, it's just a pleasure to develop these days through that. So it's actually pretty amazing. And what we've seen a lot in the last few years is that with the arrival of like Docker technologies and also Kubernetes like deployments, we're able to really like empower developers to ship like a full standing element that then DevOps and other teams can just grab and deploy, various services like like Kubernetes services, PKS and others, for instance. So the container is kind of the new output of the SDLC that developers are producing. And this is what's going to be expected more and more from basically the dev teams. And the other thing that's going to be expected more is security. So, security is everyone's responsibility. It would have been easy not to be, but it is, unfortunately. And security doesn't sit with your security team, unfortunately. It's also your problem. And if you talk to any security practitioners in your organization, they're probably like begging you to use open source and do more secure stuff as part of your development. So we're trying to really make this like a seamless process and definitely move left in the SDLC. So
yeah. And for the stuff that we're going to show today, there is so much security best practice built into it that that you wouldn't even necessarily notice. For example, just the fact that, hey, we've already got everything under version control. All the changes go through an automated CI/CD system that only takes stuff from the version control. You'd be surprised how many organizations let people build images locally and deploy them, which is super dangerous. You don't know what's on their machine. Maybe they clicked on the wrong email and their machine got got hacked and now their code is shipping malware. You don't know. And or maybe they're pushing an image that has uncommitted changes in it, and now it's out of sync with what's actually in your repo. So just having a automated build system and CI system that's doing this and enforcing it already brings so much security over avoiding those things. And then having the addition of scanning and having a Docker image that's immutable, that doesn't change, and so you can test it and know that it's going to stay the same. There's a lot that's been baked into that a lot of really smart people have been thinking about for a long time, and is leading to much more secure applications.
Absolutely. So repeatability and integrating processes in its flow is definitely key. And not everybody is there, I can tell you that, but there is a lot of transition happening, and a lot of good companies are also helping large organizations making this transition. And it's painful, but at the end of the day, that's needed, and security is definitely something that is getting really more and more like attention, funding, and involvement from everybody. We hear like this term of DevSecOps. It was like ops, and then it became DevOps. Now it's DevSecOps. So no matter how you look at it, security is coming your way. That's basically the gist of it. And the good news is that there are tools like what we built that were designed for developers. So we're more a developer tool that does security versus the other way around. So it's a good time, much better than a few years ago, I can tell you. So let's take a look at how we can bake this into basically a pipeline, both for app security and OS dependencies, so we can make sure that at the end of the day, what we ship out there is okay. So what we're going to do today is basically grab an app. It's a sample app I have on this repo here. We're going to use Codefresh to basically build this stuff and build a Docker image around it. And in the process, we're going to basically use Snyk to scan the dependencies of that application and break this process if we know that there are some issues in these dependencies. And once we have the Docker, before we decide to ship it to Docker Hub, where this is a place I want to share it with the world because I'm contributing to open source, for instance, we're going to also scan the image there to make sure that whatever is going through is using a healthy container altogether. So with that said, I will switch gear a little bit. So I will switch to the Codefresh console. So very easy to log in and to get to that. I have configured the repository that I'm going to use to get my code, and from there I have the pipelines that are aligned to it. And here we're looking at the pipeline that I've built. So I'll go over some basic items that you typically need to have for Snyk to function. So you need a Snyk token. Once you sign up on Snyk.io, you'll be able to go to account and get a token. All this is documented in a README of the repo, by the way. I specify my organization, so it allows me to compartmentalize where I want to put things on the Snyk side of things. I decide to use a given image name here. That's what I decided to use for my situation. And there is an optional step where we're also scanning the image. If you don't want to do that, that's fine. But otherwise, what we're going to do there is we're going to actually get the image from the Codefresh Docker registry, in this case that is local, and extract the image from there, test that before we ship it off to Docker Hub. So, a few steps in there. What I'm going to show you is very briefly the YAML. We'll dive into the details of there, but let's build it and see what it looks like. So I'm going to build that of my master branch. Let's see if the code that I have today is going through cloning the repo, building the image, and then starting scanning stuff. Let's see if that flies. And if that's the case, then we probably can go home early. If not, we'll probably have a couple of actions to take. So the Git clone is happening. The Docker image has been built, so we'll take a look at how it's built. You can bring your Docker file, or in that case, I'm actually using Codefresh to build the container for me. And from there, right now, the Snyk test application dependency is running. So in the backend, we'll look into the details. And I believe that I'm using a version of a given dependency QoS that is a query string parser. And I think in the version that I'm using it's not vulnerability free. So if I look at this step while this is running, I actually see it's failing. So in the output, very quickly I see some red, which typically is not good. But we found one issue in this case where QS had this prototype override protection bypass issue. I can actually grab this link and go for it. I'll take a look. It takes us to our vulnerability database page on snyk.io. You can go and see it. It's open, and I see basically it's affecting QS in these versions, and I can read more about it. And, the general gist of it is that we are able to basically use this vulnerability to kind of define your own function in a way. And if I go to the repo and I go to my application, I see in my package.json that I actually depend on this version of QS, and it's actually a different one. In this case, it's 601, 600, sorry. So I need to basically upgrade this version to 604 to be vulnerability free. So I'm going to do that in a second, and hopefully this code change will be picked up automatically and then fixed. So before I do so, just to be clarifying, we built this stuff. So we used the YAML file where we define a couple of stages. One is scanning, one is promoting after we build, right? So the first step is really building the image and building the application. So we're checking out the code from GitHub. And then in this case, I'm actually passing a given Docker set of instructions. We're using this particular image, the 8.0 Alpine. I'm moving around some stuff. I'm installing the dependencies, and this is where ready to be shipped. And then we implemented the Snyk scan portion where I call it test application dependencies. In my case, it's in the staging of scanning portion, and we're basically scanning this particular item. And for us to be able to do that, first we're installing Snyk. So when we do npm install, it actually installs the CLI version of Snyk, which allows you to then use it on your machine if you do that on your machine as well. It's a very simple command that you can call Snyk test. It will return any vulnerabilities. And what I've done here, which a lot of our customers are doing, is especially when introducing security at first, they decide to be a bit more gentle on what they decide to break the builds on and focus on really what is really high severity. So high severity, it's the struts 2 for coming from Equifax that had this issue. It's kind of the high impact, relatively easy to exploit sort of deal. And in my case, I don't want to necessarily block my build if there are low severity issues or medium ones. I want to focus really on the high ones, and the QS is part of that. So the result of this command is basically what we saw in this build here. The stage is failing, and the test has been running. You can see this is a high severity issue, and basically the Snyk results broke the build in this concept. So that allows you to really gauge what's going through. So let's do something, and I'll probably need to switch sharing for 1 second here. So I'll go to my CLI. This is my repo. I have my applications. I have my package.json. This is more in sync with the page that I need to refresh. And if I look at the package.json, I actually see that the version of QS that I'm using is indeed below the 604 version. So what I see in the vulnerability database page, actually, let me just share the whole screen, will be easier. What I see is that when I look at it here, this particular issue is impacting all these versions, including the ones that are strictly under 604. And typically the remediation is, well, upgrade to 640, and and these different versions. I see that also the 604 version was backported, the issue too. So I can actually go there and then safely go to 604 to fix the issue. It's kind of a special condition. And then from there, I can save this file, and then I promote it to GitHub. I'm going to say we're going to commit the changes, and we're going to fixing QS vulnerability. And I can just push this to my branch, and I push, in my case, to master. And that's going to be then picked up very quickly and automatically. Again, that's a nice bit of Codefresh. We're going to be able to see the build systems, and this is pending. This is being picked up. You see, fixing QoS vulnerability, and we're going to be like then watching this going through and see if we're passing the test or not. If there are any questions, so it's a good time while we're waiting for this to build.
Now, actually, while that's running, I do have a poll to ask people just who's using Kubernetes so far. In this particular example, we don't have a deploy step that we're showing, but this would be a natural sort of, the way that this flow would normally hook in is we would probably have a separate pipeline that's looking for new images to be pushed to our repo, which would then trigger the deployment into Kubernetes, but it could be into ECS, it could be into Azure container instances, it could be into other things. So appreciate you answering that poll while this builds. And this time the Docker image is taking a little bit longer to build. One of the reasons for that is that the last build we did, it was basically able to cache everything. Here it needs to update the dependency tree, and so it actually has to rebuild that from scratch. So there's a lot less cached in this instance. So we're taking a little bit of a time penalty for making that update, which is normal. I mean, the way that the optimization works on the build scanning is it actually caches every layer of your Docker image, and that builds up from the operating system to the operating system packages, and then to your application packages, and each one of those layers basically gets cached independently, and so only the layers that need to be updated will actually rebuild when we run this. So here we're taking a little bit of extra time.
So I see a few questions that I can also answer while this is going. So, you know, what scan does Snyk perform? So the scans that we're performing, we have kind of two steps here. The first one is we're extracting the dependency tree of your application. So we understand, you know, all the elements that your developers decided to use in your application to do whatever it does. And we're going to basically get this tree and sync it against our vulnerability database of known vulnerabilities for these packages, and we can tell you about it. And the idea is that we have other flows that allow you to really inject a remediation really easily in the whole SDLC process. I'll tackle the how we stay up to date with vulnerabilities, part of a couple of minutes discussion. I see here, for example, my application now is vulnerability free, so I can take a look at it. And, you know, we tested, you know, we have 525 dependencies. If you remember, like the file, the package.json, we already have like 2 packages in it. It's QoS and Node.jq. Just these 2 dependencies bring 525 of them. So it's a lot of them. And in this case, none of them contain a high severity vulnerability. Now, this is all going great, but I see now that the OS portion is actually breaking. So let me take a look at that. And I see that, that here, you know, I'm testing this particular Docker image that, you know, is the one that was just built in this step. And we tested like 13 dependencies. We found that 3 of them have a known issue. And these are like medium severity. You know, it's, for example, IPAM-based layout is bringing BusyBox in this version. And I see the R4 has an issue, and it's actually fixed in R9. So, you know, we're going to take a look at how we fix that, just to really show you like how that has been built. So this is a bit trickier to do this. We actually run what we call a composition step on the Codefresh side. So, you know, Dan can explain a bit there. But the idea is that we're going to be basically passing a given command that is going to run a Python script that is part of this particular image that, you know, if you go to Docker Hub, you can find it. And we're passing basically to that script, hey, I want to test this particular image. And we have a couple of mechanisms that are using, you know, these particular credentials to basically get the image from the registry that Codefresh hosts to grab the image and test it. And then from there, the Snyk process does what it does, returns vulnerabilities in a very similar way to the app mechanism. We extract the dependency tree. This time is for, you know, OS level dependencies, stuff that, you know, your base image brings and this sort of deal, to be able to then sync it against our vulnerability database and see what's going on. So If I actually look at the image that's, Codefresh generated before, I see node 8 Alpine. So, I know that the latest version is 10. There are other ways to actually understand which version you need to go to, but, here for the sake of time, I know that this base image probably fixes a bunch of these problems. So I'm going to update this manually. If you have a Docker file typically on your repo, and that's the way we would suggest to do that moving forward, you update your Docker file, you update your base image, and from there you save this and you restart the build. So we're going to be, let me just do that here. We're going to kick off the build, and we're going to go through this process again. And this time, I think it should go through. So
yeah, so while it's doing that, and we can answer a couple of questions, I did want to put out a poll to ask people what they're particularly interested in scanning here, because obviously there's really two different things. One is your application libraries, which is language specific, and the other is your Docker image, which is sort of distribution package manager specific. So interested to hear what people have to say on that. And we do have a number of questions. Maybe we can answer one of those while this is building. Ernest asks, how does Snyk stay up to date with vulnerabilities?
Sure. So, we have an office in London and another in Israel, and one in Tel Aviv, actually, and another one in Boston. And we have a strong team in Israel. They all came from the Israeli army in many ways, and we have a lot of security expertise there. So what this team does is looking at these vulnerabilities, where they come from, and usually they come from 3 or 4 different sources. We look at the CVs, the NVDs, databases, all the public database ecosystem that collects this stuff. And what we do is we grab these elements and we get through a pipeline that security teams reviews, and we make sure we inject only what makes sense to inject in our DB. We also do GitHub repo scraping, for instance. This is where usually things live. We're going to look for stuff that seems to indicate some security issue in a PR, on a comment on a PR, or on a GitHub issue, something like this. Same way it gets flagged, reviewed by our security team. We have a lot of accuracy in what we inject, and also remediation steps, because we actually enable automated remediation when we integrate in the repo directly. And we do our own research. So, if you look for zip slip, for instance, on Google, we released that a couple of months ago. It was a pretty big one. So, we keeps us sharp, gives us a good way to help the community by opening PRs to fix these issues. And we actually have communities and customers also reaching out to us. A lot of people find stuff, but they don't like the responsible disclosure process. So we help them going through that. And in the end, is a few different type of sources that we get that aggregate a lot of issues that may or may not have CVs associated. Actually, a lot of them do not. So, let me see what is going on here. It's
looks like we still have something vulnerable.
Yeah, and I'm going to check why. Usually the 10 Alpine does the trick. We need to take a look at one thing. Apologies.
Now, in kind of the old world, people might not be doing this type of scanning, so they may not be aware of the issues, but oftentimes it's the operations team, the DevOps team, that actually finds these things. And then they have to go through a back and forth with the engineer to say, hey, you need to go and fix this. What I like about this flow is that here Antoine is making the change, and he's basically getting the feedback instantly that there's a vulnerability he needs to deal with. And we didn't show it here, but he could set up the Slack integration so that when the build fails, it sends an alert and says, hey, there's an issue, you have to go and deal with it. Takes him right into that flow where he can see exactly what went wrong and what needs to be fixed. And from our poll results, it looks like we had a pretty good mix of languages here, but most people very interested in scanning the Docker images. So that's good. We got the right people to come and watch this video. While you're doing that, there's 1 or 2 questions that I can probably answer. And when you're ready to narrate, feel free to jump in and.
Mm-hmm. Yeah, go for it. I kicked it off again. I think there's a little glitch in the update, but while this is running, so we support, there's a question about supporting organizations. So, Snyk, the way we are organizing is by organizations. You can have multiple organizations, and typically organizations group project that kind of belong together because it's the same team or something like that. And we have a concept of like a different hierarchy that allows you to look into multiple organizations. So we have ways to scale this up. We support like large enterprises that obviously have these needs. So, ping us, we have plenty of options for you there.
Yeah, and the comment from Ernest where you asked that it feels like it might be cumbersome. I'm not sure entirely what you mean, but I think what you might mean is that it's cumbersome to have to attach the credentials into every pipeline. Now, what we didn't show is you can actually create a shared configuration across an account where your Snyk token, which is encrypted, is available for across pipelines for people to consume as a shared configuration that basically you define once and people can pull in and access without getting the token access with it. I don't know if that entirely answers your question. To ask another, to answer some more questions here, Roshan, you asked, what scan does Snyk perform? Really what it's doing, and Antoine, feel free to jump in too, but really what it's doing is it's looking at two different sets. One is the code set, right? So if you're using Go, if you're using Python, all those languages have their own package managers, and is looking at all the packages in your code base to see what vulnerabilities there are. The second is looking at the operating system level and operating system package level. So this is when it does a Docker image scan and it looks through Debian Package Manager, RPM Package Manager, Alpine Package Manager. And if you do something like install the Apache APK, for whatever version, it can scan all of those packages that you have installed on your operating system and then expose those vulnerabilities to you so that you can catch them and fix them. So hopefully that answers that question. So Antoine, what do you think you were diagnosing the vulnerability there? Was it just needing to update Alpine, or what was the thing, do you think?
Yeah, I think the image, when I modified it, the image is not getting updated because that goes very quickly. So it's probably using the cache version that is Node 8. And I'm not sure why.
Is it still showing Node 8 in your scan?
In my scan, no. But like that goes pretty fast to be caching it, and I know this image doesn't have any issues because I tested it.
Okay, so let's on that build, click the little arrow on it, and oh, sorry, actually click the build.
Oh, let's see. Yep.
Do it from here. This should give you and go to advanced options. And go ahead and check ignore Docker Engine cache and ignore the next cache too. And go ahead and just reset the pipeline volume.
Okay.
Yeah.
I think it's that.
So if it's a caching issue, then we would see it happen. Normally using a Docker file from a repo is the kind of standard use case, but it is kind of nice here where we can edit it live. Also, that Codefresh YAML normally stored in the Docker repo. If you go and look at the example repo that we provided a link to in the chat, you'll see that the Codefresh YAML is actually in the repo, so you can just grab it and add it to Codefresh from there. And it's under version control that way, and we're not editing it live. This is better for demo purposes. It can be really useful for debugging purposes as well. While that's going again, Roshan asks, the scan is only expected to happen in the build phase and not in production environment. This is my assumption. Is that correct?
So the scan is something that you can run like anywhere. It's really like a simple command that you can run. Typically, the CI/CD pipeline ships something to production. We do have integration, if it's like a serverless environment or like Heroku or Cloud Foundry, this sort of deal. We have the ability to also scan what's out there. But the idea here is that the pipelines leading to production will have multiple stages, and we can be in all of them if you want. It's a bit up to you, and it depends a bit on your pipeline. We can help you like steer things a certain way, but the idea is that it's going to be like following the path that you define, and you'll see where it matters best to run this test.
Yeah, and I think from a best practice standpoint, having it in the build phase is my preferred option. One of the reasons that I like that is because here we have Snyk actually being installed, the Snyk CLI installed, but it's only within this environment. Whereas if I needed to install it in production, that's one more thing that I have to have running in production, right? So,
and we want to be more to the left as possible, so we can catch the issues as early as possible, also to quickly and efficiently remediate them.
Ernest asked, does Snyk keep history for vulnerabilities?
Yes, we do. Like you can, every time we take a snapshot of your dependency tree, we actually can get back to it and show you like the evolution of things.
All right, so this one failed too. Let's see if we can figure out why it didn't work. So it doesn't seem to be a caching issue. Is it reporting, if you click on it, is it reporting vulnerabilities?
Yeah, it is. Sorry, that's downloading your image, and that should be okay then. Let's see. Image name, same.
Some of these vulnerabilities may have been found since you ran your test before this.
Well, I wouldn't think so, but the idea was to really like grab this element, and that's using this image. And basically when you upgrade to Node 10 Alpine, this test passes because there are no vulnerabilities in that base image. So that's the idea. I'm not sure exactly why this is.
So that would include, because I'm seeing BusyBox is throwing a vulnerability, and
it's the same vulns that are in Node 8. So okay. It's a demo time. I've tested it like probably like 20 times before, but I'm not sure what's going on at the moment right now.
Let's see. I wonder if the image that it's pulling is not the latest image that we built. Because it is saying, but it is saying downloaded newer image. Have we pushed the image yet? Yes. Well, yeah, we built it, so it's pushed into that repo.
That's what I'm thinking. Yeah. Mm-hmm.
Marked as training app. Let's see.
Yeah.
I see the image building. So if you click on it, well, I'm just looking at the logs here, but if I'm looking at that building Docker image, it says that it is building from Alpine 10. And oh, actually, wait a second. Error. Configure disable maintainer mode prefix make install command failed .configure configure error no acceptable C compiler found cconfig.log for more details. But it didn't exit with a no one exit code. Seems to be that there might be an issue with the Docker image itself. But it is getting tagged and built and pushed to the repo. But it does look like it's scanning an old one.
Okay. Let me take a look at something and simplify it a little bit.
I do see the commit. We reset the cache. Production. Everybody loves a live debug. This is the best parts of demos.
Okay. Try that again. And while I'm trying again here, modifying a couple of things. So while so when you perform the scan, we find things and we flag them. what we're trying to do is trying to get earlier there to in the SDLC, typically around the repo as well, so we can flag things as you're basically submitting a PR in your code, and we're going to flag if this PR is introducing anything new. If that's the case, we will also provide like remediation steps. If we're integrated in the repo, actually, we have the capability to open pull requests, pre-positioning how to fix these issues, so you can quickly like test and merge the remediation. So we list out what you should be doing about which version you should go to, this sort of deal. But we're also trying to really pre-position these changes in a form of a pull request. So it's really easy for developers to not to have to figure out what to do, but rather test the steps and then merge it. From there, like you can ship it into your pipeline and then fire it off and deliver what changes you wanted to make.
Would you click on that building Docker image while it's going? Just wanted to see what the logs say here.
I got that again.
That's where it's getting the error on install binary.js, but it doesn't throw enough of an error to actually kill the build. Somebody suggests in the chat, Michal suggests that Node 10 may have dropped tools from the image, and they might have dropped something we need in the build modules. I don't think that's a bad hypothesis.
It's definitely a possibility. Let me see.
While this is happening, Ernest asks, if Snyk is down, what happens to the pipeline? Will the build get killed? Yeah, I believe that Snyk would error out, right? And so that would throw a non-zero exit code, which would end the pipeline, correct?
Typically, yeah. So we make sure we don't go down. Basically, that's basically it. But yeah, there are various ways you can address that. But typically, we're up and running. We literally 100. We run I think 150,000 tests every night for project we monitor and stuff like that. So it shouldn't be too much of a concern typically, and it's at least it's not something that in a year I've been at Snyk I got to experience. So
yeah, and it would, I mean, basically would try to reach the database and not find it, and so it would throw an error.
Correct.
Yeah. So it would stop the pipeline. Let's see.
Something, and otherwise I'll switch gear a little bit.
Michal suggests, I think you can fail fast equals false on Codefresh side, but I would imagine you want to fail if you cannot scan, so that you don't accidentally release something vulnerable. That's true. We could add on the last scan step a fail fast, so it would fail but then finish promoting to Docker anyway. So that's a preference thing, I suppose, if you want to do that or not.
It depends how you want to handle that, obviously. So if you rather build and ship no matter what, or if you want to be more conservative and not ship something unless you're sure it's okay. So we see a little bit of both. It depends a bit on your level of priorities around these elements, really. So it's definitely something that can be adjusted. It's
yeah. So and then Roshan asks, does Snyk also suggest corrective measures to fix the vulnerabilities? And what I'm seeing looking at it is that it's telling me that this version has this vulnerability. The remedy is often to update the version, but it seems to suggest other things if another action is needed, right?
Yeah, so the remediation is something that if you look at here, we have a great path, upgrade processes that help you figure out what to do. If you're integrated around like a GitHub repo, for instance, we have the ability to actually open a pull request to fix this particular issue. So it's something that's pretty powerful, and a lot of people like it because it's, again, I don't need, as a developer, typically I don't care what the issue is about. I just want to fix it. So we're really trying to take the additional step there to be like, you know what, just go open the PR, go for it, and you're good to go. So like I can show you this very briefly. It's not really like in scope, but this is the application. I have a bunch of issues there that were listed. I can actually open a pull request there and then really take this to the next level, decide what I want to fix in there. You can pick and choose. And if you decide to fix all this stuff, you can actually go open a pull request. It will send you to GitHub, for instance, or something like that. It depends on which system you're using.
And this is for the code scan, not for the image scan.
This is for the code scan for now. We're going to bring that for image scan as well in a pretty short order. But the idea is that we're trying to really take a step further. We here leverage the PR mechanism. The CI/CD pipeline tends to be more like something that is more like gating in a way, rather than actually doing something about it per se. So it's just when you're in a CI/CD pipeline, if you want to actually remediate something, you will need to go back to the code and fix that. So that's a bit the deal there. Let me just do something very quickly, and we'll get this going. This out of the way. This. Let's see if that works better instead. So, I made a few tweaks. I should have a build being picked up, and hopefully that should go. Yes, we are SOC 2 compliant. We can provide the SOC 2 report and all this stuff. So, with I love security questionnaires. But so the idea is, when the test passes, and we don't have an issue like building the Docker image and the dependencies, we are going to be like having this as a green, and then we'll just push it to Docker registry. So this step is really optional. You can push it wherever you want. It doesn't really matter. It can be your own registry. It can be against Artifactory, your Nexus, like wherever it lives. It's just whatever makes sense for you to deploy this application. And if that fits into a multi-stage, pipeline sort of setup, you can easily replicate this concept of like scanners across the board and be able to to do things accordingly. So that's something that should fly. And downloading a newer image. And let's see. I still have these issues. Okay, interesting.
So, okay, then. This is phishing, but I'm going to add a GCC build base as a thing here, because that seems to be the compiler issue. So we've run that.
To restart the build.
I just did. So if you can go and look at the builds and see what it does. With that, I think we've answered all the questions. We'll debug this for probably another minute or two. Let me share my screen one more time. Or actually, if you just want to go back to the presentation. One thing we wanted to add, going to the next slide. This one is that this basically represents two new Codefresh plugins. One is the code scan, and which can do all those different modules. Now, the example that's in there right now is for Node, but I did see that there was a lot of interest for other ones, so we'll have to go and add those in. The other is to do the Docker scan. You can find both those steps and the instructions for replicating this entire thing on this GitHub. If you run into any issues replicating it, please create an issue. We'd love to see that feedback and make any adjustments there. And then the last thing that I'll do is, and we'll continue debugging this, we'll see how that build went. I do have a short poll just asking how this went, and if you're interested in trying Codefresh, if you're interested in trying Snyk, that's great feedback for us. We put these together and we try to make them really effective for people. Sometimes it works, sometimes it doesn't, but we'd love to get your feedback on it, and to understand how we can do better. So it looks like my gambit of just adding the build base made some angry noises. So I think we'll probably leave it there, and we'll figure it out and add it into the repo. So looks like we just have a security vulnerability that we need to address, which is fine. This was the purpose of the pipeline, right? So so it's working as expected. We just might not be as good at fixing the vulnerabilities as we'd hoped. But anyway, I hope everybody enjoyed that. Do you mind going to one more slide forward there, Antoine?
Sure.
I did post a link to that in the background. Codefresh does have 120 builds a month free, so feel free to go create a free account. We'd love to give you a one-on-one demo or give you an onboarding session where we can basically brainstorm how we migrate your pipeline into Codefresh and get you up and running as quickly as possible. We do that for free. It's no cost. And then for Snyk, I believe that scanning code is free and images is premium. How does that work, Antoine?
Yeah, so if you want, you can sign up on Snyk.io. You have 200 tests per month for free. You know, it's not like you have less result or anything. You get the same quality result as anybody else paying customer. And for the Docker scanning specifically, so ping us. Will enable you to try, but it is something that is paid, at least currently.
Okay, great. Thank you very much. Well, with that, I think we'll end, and then be sure to go to codefresh.io/events to see all of the upcoming live events that we're doing. We have a number of them coming up. We're also doing meetups over there. You can see all those. And very shortly, we'll be sharing news about a new plugin directory where you're going to be able to see plugins like Snyk and many others do security scans, build images, deploy to Kubernetes, do blue-green releases, install Helm packages, all these kinds of steps and plugins that we have in Codefresh. Codefresh is really like a package of Lego blocks to help you build your perfect pipeline. And so we encourage you to go and check that out and follow us on Twitter so you can get the latest on that news and see other events that we have coming up. And with that, thank you very much. We appreciate you coming. Have a great day, and go replicate this. We appreciate it.
Well, hello, everyone. Just a quick follow-up on our session today. We actually figured out what the issue was, primarily sitting in between the screen and the chair. So what happened exactly is that we were going to have the image pulled from the Codefresh registry as an intermediary step before we're shipping it out to Docker registry. And the scripts is programmed to default to Docker registry if the login to the Codefresh registry doesn't work. And what happened is I made a typo, basically. So that was failing a bit too silently. So this is something we're fixing. But when we're pulling from the right image, we're going to go through the first build where we're going to fail exactly as before. You know, we're still using the Node 8.0 Alpine image. So we're going to still break this portion here. And then from there, we're going to fix it. And this time it's going to pull the right image to be able to then pass successfully and push to Docker registry so we can distribute our application. So we're still going through the same process here, cloning the code as before. Codefresh is building the Docker image for us. We're doing a first test here for application dependencies to make sure that the application that we're crafting into our container is not containing any vulnerabilities. So, we just passed that successfully. You can see we tested 525 dependencies again. And in this case, we didn't have any issues. And then here, we're going to then pull this image, and you can see that now we're pulling from the right location. And, we're still finding 3 issues. So that's going to fail because, again, the Node 8 image. So what I can do is I can go back there and basically update this, which I happen to know is fixing the issue. This information of knowing that this is going to be fixed in Node 10 is something we're going to expose in the result of Snyk pretty shortly. We're going to guide you much more through the remediation process, so you'll understand more what you have to do there. And going through this again, and this time pulling from the right location, we're still going to clone, build the image, and these 2 scanning tests steps will pass, and we'll end up pushing this to a Docker registry. So really easy to replace a Docker registry by your own private registry. That can be part of, that's typically part of the Kubernetes deployments. Your pods can then be automatically restarted with a new image and all this stuff, so you can really streamline the whole process and be vulnerability free in the way. So we're going to let it through here, and that should be it. So again, the bug is human-based as usual. Nothing new there. So take a few seconds, and then the test will pass. If you have any questions on anything, you can ping us on Snyk.io or Codefresh as well. Security questions on how we can scan stuff, definitely ping us. Dan and I are in sync. So anything that is helpful, let us know. We're happy to help. The product is evolving, Codefresh product is evolving. So there are a lot of really good stuff that we have on our respective roadmaps that I think will be addressing a lot of your needs to, again, go through this operation of automating your deployment, so you don't have to worry about deploying things, but rather really focus on the development bit and providing the value that that you are providing during development. So not worrying about the rest and still delivering high quality elements. So we see we're picking it up from the right place, and this time we tested and no vulnerable paths were found, and we're passing this successfully to then push to the Docker registry, in which case, it's going to be pretty straightforward, and we're grabbing it from this location and putting it in this location in the docker.io. And once complete, we'll be all set, and we have a successfully built pipeline. So from there, I can just work on my code. I don't really need to be in this so much. I can, hook it up to a Slack channel notification. I can put a badge on my repo and then make sure that I don't necessarily have to go back in there. As long as it's passing my build, I probably don't need more than that. Thank you for watching, and again, ping us if any questions.